Hello guys, today we are going to do the parts and assembly of the machine voice. So let's start with the part number 1, that is the body of the machine voice. Select sketch, select the front plane. Now as usual, first draw the rough part of the machine voice body. Check all the dimensions. No, now uh, assign the dimensions as it is given in the details of machine voice. We can go from the shortest to the longest, that is the ascending. Set this dimension as 5. Set, and this would be, sorry, this is 25, this is 40, this is 57, this is 85. Need not to worry about the shape, it will be corrected as we go on giving dimensions. This is 220. As you can see, the shape is corrected. The dimension given in the machine voice is 230 for this dimension, but at the end there are two curvatures, that is at this end and this end. So the total length from this end to this end after the curvature is 230, but we are going to do that later. So we are going to take only this these two parts, and the length of these two parts will be 220. Now we have to use the fillet option and select this and this part and give a radius of 10. As you can see, from here to here it is 40, and from here to here it is 35. Now go to return, or else you can place it centrally also. Use move option from the select from the midpoint, that is from here to here, or else you can directly do with another option, that is from here to here it would be half, that is 110. Now you can see it is placed centrally. Go to return. Now you have to give protrusion of select protrusion, select the sketch, click on green tick, using symmetric of extent option, give a protrusion of 100. Now you can see the main body part is formed. Now hide the sketch. This is the top part, this is the front, this is the left, this is the right, and this is the isometric. Now let's go ahead with the other parts that should be made in this body. First select sketch option, or else revolve it a little, then select the sketch option and select this plane. Now fit it, draw a rough diagram of the cutout that should be made. Sorry. assign the dimensions. This is 20. The distance between from this to this is 26, and distance from this, the distance from this to this is 30. Distance from this to this is 10. Distance from this to this is 13. Yeah, all the dimensions are set. This is 20, this is 26, this is 13, this is 10, this is 30. Now, using mirror option, select the sketch, select the center axis, left click. Now we have got the sketch. Go with return command, select cutout option, select the sketch, click on green tick, and the distance that should be used for cutout is 220 minus 40 minus 15. Click on enter and left click. Now we have got the cutout that we are needed. That is the total cutout length is 165. This is the top view, this is the front, and this is the isometric. Now hide the sketch. Now we have to make that curvature part that I had mentioned earlier. Go with the sketch option, go with this surface. Now draw a circle of any diameter at the start. Assign the diameter as it is given in the details of Machinewise. The diameter of this circle is 32. The distance of this circle to this plane is 30. Go with the return command. Use protrusion. Click on this and give a protrusion of distance 5. Click on left click. Hide the sketch. Use the round command and select this thing and give a radius of 2. Click on preview. So you can see, or else you can do after protrusion of length 5, you can give a radius of 5 round option. Go with the round command, select this edge, give radius of 5, click enter, click on preview. As you can see, the curvature part is formed on this surface. Now go with mirror copy feature, select the round option, click on smart mirror copy feature, click on left click and click on the axis, this axis. Sorry. Go with mirror copy feature, select smart, select the round protrusion and round, click on mirror copy feature smart, click on green tick, select the plane. Now you can see the same thing has been found on this surface also. Now we have to make a cutout in this curved part. First select this part, select the sketch and select this part. Now we have to draw another circle here, and the diameter of that circle is 20. First select the circle option, draw a circle of diameter 20, or else draw a circle of any diameter at the start from the center. Sorry, select circle option from center, draw a circle of any diameter at the start using smart dimension. Give the dimension of the circle as 20 diameter. Go with return, select cutout option, select the sketch, click on green tick. Now do not give the whole extent, as we have to do another circle here of another dimension. Click somewhere here. Now we have got the circle cutout of diameter 20. Now we have to make the same cutout of dimension 12. First click on the sketch. Before that, hide the sketch number 4. Click on the sketch, select this surface from the center, draw a circle of any diameter at the start, and using the smart dimension command give a circle of diameter 12. Go to return, select cutout option, select this, and now you can drag at any length and give a cutout. As you can see, here the cutout of 20 is given and here the cutout of 12. The sketch. This is the top view, this is the front, this is the left, this is the right, and this is only the isometric view. Now we have to make the holes in this body part. Let's go with the hole option, and the hole should be made here. Click on the hole properties. The type of hole is countersink hole. The diameter is 3. The countersink diameter is 5, and it should be through next. Click on OK. Now from this axis it should be placed here, and the distance of this hole from this end to the hole is 20. Now go with return, click it downwards, go to the front view, and using the visible and hidden edges you can see the hole that is made, the countersink hole. I'll zoom it once. You can see the countersink hole. Go to return, go to isometric view. Let's do the other hole, and the other hole should be made on this surface, and click on the hole properties. It should be countersink. The diameter is 3 and the countersink diameter is 5, and it is through next. Click OK. Place it here, and the distance from this to this circle is 10. Go to return, select downward option. Again go to front view and select the hidden and visible edges. You can see the countersink hole. I'll zoom it once. The countersink hole that is formed, and it is at distance 10 from this to this. Go back to isometric view. Now still two holes should be made. Select the hole option, select this surface, go to hole properties, select threaded, threaded, go the diameter of hole is 5 and the thread type is M6. The finite distance of the thread is 10 and the hole depth is 13. Now click on OK. Place it here and another one here. The distance between these two holes is 60. That is the distance from this plane to this, it should be 30. Now the distance of these hole is 60 and another distance that is from this hole to this is 12.5. Click OK. Now everything has been made. Go to return, give the backward direction. Now as you can see, the threaded holes have been made. You can go with the left view. The two holes have been made here. In the front you can see the holes using the visual and hidden edges. Now go back to isometric view. Now all the holes have been made. Let's complete the remaining part. Select, before selecting, rotate it a little, select sketch option and select the bottom surface. Now draw a line from here at a length of 40. Fit it. You can check the length using smart dimension. It's 40. Now draw another line of length 40 using connect. Select the midpoint of this line and select this line. Now it is placed centrally. Draw another line of any length at the start. Give the length of this line as 120 degrees. Sorry, length of 120 mm. This should be 120. Even this should be placed central using the connect. Use the midpoint and select this line. Now it is placed centrally. Connect these both lines. Now using fillet option, this and this, it should be of radius 13. This and this should be of radius 13. Now we have got the diagram. What we have to do is we have to protrude this region. Go with return. Rotate it a little. Select protrusion. Select this sketch and give a protrusion of select protrusion, click on green ticks, give a protrusion of 20. Now hide the sketch. Now the cutout should be made in this part that is protruded. Select sketch option, select this surface. Now draw a circle using this axis as center plane of any diameter at the start, and give the diameter as 16 because the radius that is given is 8. The diameter will be 16. Now this is at a distance of 13, that is the circle is at a distance of 13 from this line. Use the line from here, join to this, from here join to this. To make sure these are joined, use a tangent option, select this line and this. As you can see, it is showing the requested change conflicts with the existing relations, that is it's already tangent. Again, you find for this line also. Connect this, or else before connecting trim this excess part. Now join this line. Use the offset command. Give the offset as 5 of distance 5. Select, click on green tick and click on left click. Now as you can see, the part has been made. Now trim off the excess part that is not needed. Okay, connect this line from here, or else use the trim corner. Select this, I'll go with edit. Else again trim off the full part. Select this and check it's solid or not. Yes, it is. Use the offset command. Use the offset. Click on green. Give offset of distance 5. Click on green tick. So the offset is taking as lower distance 5. Select the parts. Click on chain. Click on left click. Yes. Now the part has been made. Remove the excess part. Before that, connect these two lines and trim off the excess part. Before protruding, zoom the area and see that there is no excess part left out. Here there is a little. Now you can see there is no excess part left out. It's perfect. Go to return. First, using protrusion command, protrude the surface for a distance of okay, the part is not joined correctly. Need not to worry. First, go to select tool command, right click on sketch 7. uh, there is an option known as edit profile. Click on that. Now connect these two lines. Now they are connected. Go to return. Now the part is edited. Select protrusion, select the sketches, click on green tick, give a protrusion of distance 3, click on enter. Now the protrusion has been found. Hide the sketch. Before hiding, you have to this cutout left out. Select the cutout option, select things to be cut, click on green tick, click on symmetric extent, and now click on left click. Now you can see the cutout has been made, and this is the shape that we are in need. Hide the sketch. In the top you can see the part that we are in need of. Now go to front plane, right, left, and go back to isometric. You can see this is how it looks. Now you have to copy this same thing on the other side also. First evolve it as you want. Now using mirror copy feature, select the things to be copied. Click on smart feature, click on green tick, select the axis. Now as you can see, the body part is ready. This is the top view, this is the front, this is the left view, and this is the right view. Go to the front view. You can check with the line, visible lines and edges. This is how the body part looks. Now let's go ahead with part number 2, that is a movable jaw. Select the sketch option, select the front plane. First draw the rough diagram of the sketch. Sorry, this should be axis. The rough diagram is ready. Assign the given dimensions as it is given in details of machine wise. go according to the ascending order. This is 3, this is 5, this is 10, this is 25, this is 35, and finally this is 50. Now go to return. Sorry, before protruding, we have to do some changes. Select the select tool, go to the sketch number 3, right click on it, edit profile. First we have to chamfer a little using fillet option. Select this line and this line, give a radius as 3, and now select this and give a radius as 10. Sorry, select fillet option, give a radius as 10, select this and this as 10. Now it is now this part is ready. Go to return, select protrusion, select the sketch, click on green tick, select the symmetric extent, give a distance of 100. Now hide the sketch. The part is ready. Now we have to make the bottom part. Select the sketch, select the bottom part. Now draw 2 lines. The line should be symmetric. Select symmetric relationship, select the axis, select the 2 lines. Now join the lines. Sorry, click on the line option, join the lines. Now the distance between this and this is 40. Now go to return, select the protrusion command, select this sketch, click on green tick and give a protrusion of distance 45. Hide the sketch. Now this the part is ready. We have to make the holes in it. This is the top view, this is the front, this is the left, sorry, this is isometric, this is the left, and this is the right view. Now the body part is ready and we have to make holes in it. First select hole option and select this surface, click on the hole properties. The type of hole is threaded, the diameter is 20, the type of thread is TR20 into 2, and it is to the hole extent. Click on OK, place it here, and the distance from this to this is 27. Select this and make it as 27. Now go to return, click on the backward direction. As you can see, a threaded hole is formed. Now we have to make holes on this surface. Select hole properties. The type of hole is threaded, the diameter of hole is 5, the type of hole is type of thread is M6, finite extent is 10, and the hole depth is 13. Click on OK. place it somewhere here and here. The distance between these two holes is 60. That is the distance between this to this hole is 30. Now the equidistance and the distance from of these holes from this line is 15.5. Now go to return, click on the backward direction. Now you can see a threaded hole is made. Now we have to make the another two holes on the bottom part. Select the hole option, click on the bottom surface, click on the hole properties, click on threaded part. The hole diameter is 5, the type of hole is M6, the final distance is 10, the hole depth is 13. Click on OK, place it here and here. Now the distance between these two holes is 24. That is distance between these two is, sorry, the distance of this hole to this is 12. Delete this. Now the distance between this to this is 25. So goes to this, go to return, click on the upward direction. Now as you can see, the holes have been made. Now the second part is ready. This is the top view, this is the top view, this is the front view, this is the left, this is the right, and this is the bottom view. This is the isometric. Okay guys, now we will go ahead with the part number 3, that is jaw grip. Now go to the sketch, select top view. First draw a rectangle of any dimensions, then set the dimensions as it is given in the details of machine wise. Now this would be 28 and this would be 100. Use connect command and select the midpoint and this axis, and select the midpoint of this and select this axis. Now it is placed centrally. Now go back, go to return, select protrusion command, select the sketch, click on the green tick and give a protrusion of 8. Click enter. Now we have got the rectangular block. Now hide the sketch. Now we have to make two holes which are at a distance of 60 to each other. Go to the hole option, select the top surface of rectangle, go to the hole properties, select countersink hole, give the diameter as 6.3. Countersink diameter will be 12. Countersink angle is 82. Now it should be through all. thread is not required here. Click on OK and make a hole right here and another right here. Now go to the smart dimensions, select the circles and give the distance as 60. Now go again with this smart dimension, select this circle and this axis, give this as 30. Now both are equidistant from the axis. And now these two circles are at a distance of 12.5. oh, sorry, select this circle and with this okay, do not place it on the axis. Go again with the hole, go to the properties, 6.3 12, if everything is correct, to all, place it somewhere here. Go with the distance as 60. See that these two are equidistant from the axis. Give this as 30. Now the circles are at a distance of 12.5 from this axis. Now we have done everything as per the details of MachineWise. Go to return, select downwards and click OK. Now we have got the hole with the countersink as required. This is the top view, this is the front, this is the right, and this is the isometric view. Now save this part. Now we will go ahead with part number 4, that is screw. Select sketch, select front plane, do a rough diagram of the screw. Now set all the dimensions. You can go with the shortest to the longest, that is ascending wise, so that it will not cause any confusion, or else you can go anyhow. This is total is 6. Now as we are doing only half part, we will be giving it as 3. This is totally 12, but as we are doing half, it would be 6. This is 3 and this is 16. Now go to return, go with revolve protrusion command, select the sketch, click on the green tick, select the axis and give 360 degrees of rotation. Hide the sketch. Now again go to the sketch and select the front plane, zoom the area. Now we have to make a cutout in the shape of a rectangle. Do a rectangle of any length and width at the start and now set the dimension as it is given. The depth is 1.9 and this is 1.6. Go with connect command, select the midpoint and select this axis and go with the collinear command, select this line and select this. Go with return, select cutout, select the sketch, click on the green tick and click on the symmetric extent. Now we have got the cutout. Hide the sketch. This is the top view, this is front, this is right view, this is isometric. Now if you want to edit the sketches that we have done at the early stage, go with the select tool, go on the sketch 1 or sketch 2 which you want to edit, right click there, there is an option known as edit profile, click on that. Now you can edit anything that you want to and go to return and click on finish. The editing will be done. Now let's go ahead with part number 5, that is screw rod. Go with sketch, go with the right plane, select the circle option, from the center draw a circle of any diameter. Now go with smart dimensions and give the diameter as it is given in the detail of machine wise. The diameter is 32. Go with return, select protrusion, select the circle and give a protrusion of distance of 40. Hide the sketch. Now again go with sketch, select the end part of the protruded circle, again draw a circle from the center and the diameter of this circle would be 20. Go with return, select protrusion, give a protrusion of 170 plus 40, 170 plus 40, that would be 210. Left click. Now we have got the protrusion for the second circle of distance 210. Now again select the sketch, select the end part of the second protruded circle, again go with circle command and do a radius of the diameter of 12. Go with return, again select the protrusion command, select the circle, green tick and give a protrusion of distance 18. Now a last part should be done. Again go with the sketch, select this end part of the circle. Before doing that, hide the sketches, that is sketch number 2 and sketch number 3, so that it will not cause any confusion. Select the sketch, go with this part of the circle, again draw a circle from the center. The diameter of this would be 10. Go to return, select protrusion, select the circle, green tick, give a protrusion of distance 22. Sorry. Now the solid part is done. Now we have to make thread forms and the holes. First we'll make the thread forms. For that, hide the sketch number 4, select the thread form, click OK and select this part, and the thread form for this part would be M10. Select this part and select the part of the protrusion number 4 from where you want to start the thread. Select this end part. The thread should be formed to the complete cylindrical part of this protrusion number 4. So select to the cylindrical extent, and the type of thread is M10. Click finish. Now you can see the thread is formed. Now again the thread should be formed on this part of the protruded surface. Select this protrusion number 2, select this end part. Now we have to make a protrusion only till the finite extent. Give the finite value option and select the distance of 170, and the type of thread is 20 into 2, TR 20 into 2. Click finish. As you can see, the thread form is formed, but as this version is 2018, here the thread, no matter what distance you give, it will take full, but when you convert it to 2D, the exact threading will be formed. Now the thread forms are formed, we have to make the holes. Select the sketch option, select the front plane. Now draw a circle of any diameter. Now set the diameter as 10. The distance of this circle from this part would be, sorry, the distance from this circle to this part is 20. Now it is placed, oh sorry, it's wrong. The distance from this to this is 20. Excuse me. Excuse me. I'm sorry. Yeah, the circle is at the distance of 20 and it should be placed to remove the circle from its center point to this axis, or else. Now let's go ahead with part number 6, that is washer. Select sketch option, select the top view, draw two circles from the center of any diameter. Now give the diameter for the first circle using smart dimension as 10.5. Now the diameter of the second circle would be 32. Go to return, select protrusion command, select the two circles, click on the green tick and give the protrusion of distance 3. Click OK. Hide the sketch. Now the washer is formed. Now you have to give the chamfer of setback 1.5. Now as you can see, the washer is formed. This is the top view, this is the front, and this is the isometric. Now let's go ahead with part number 7, that is nut. Select sketch, select the top surface, or you can say top plane. Now draw a rectangle of any length and breadth. Now give the dimensions as given in the details. Give this as 17 and this as 18.72. Now many people would have a doubt. We can directly form the hexagon by running the run macros command, but here they are given two dimensions. that is 17 and 18.72, but in the run macaron command it takes only one dimension, so we have to form the hexagon manually. Now as the rectangle is formed of given dimensions, now go with the connect command, select the midpoint and select this plane, select this midpoint and select this axis. Now uh, draw, select the line, draw from this point at an angle of 60 degrees of any length, click OK. Again same goes to the down part, give the angle as -60, OK. Now from this point draw a line of angle 120, click OK. Now again draw another line of angle -120 and click OK. Now trim off the excess part that is not needed. Trim off this part also. Now this is the hexagon of the dimensions that we are required of. You can check from here to here it would be 18.72 and from here to here it would be 17. Now go with the return command, select protrusion, give a protrusion of distance 8, click OK and hide the sketch. Now we have to make a threaded hole on the top surface to the entire extent. Go with the hole command, select the top surface of the nut, go to the hole properties, select threaded hole, give the diameter as 10 as it is given M10, go to the hole extent, even the thread should be of hole extent, click OK and place the hole at the center. Go to return, select downwards. Now you can see the hole is formed with the threads. Now we have to chamfer the edge parts. Go with the sketch, go with the front plane, select the select the line command, select this option, give, draw any line and the angle select the angle between command, the angle between this and this line, it should be 60. Now go with complete this diagram with any shape. If you can do it at this edge or you can place it somewhere here also, it depends how much chamfer you want. And now draw an axis and use the construction command, select on this line, go with return, select revolve cutout option, select this sketch green tick and select the axis and give a revolution of 360 degrees. I'm sorry, but the cutout was too short, need not to worry. Go to the select tool, select on sketch number 2, right click on this, go with edit profile. Now move this triangle from move, select move option, select this entire triangle, move it from this point to somewhere here, go to return, select revolved cutout, select this and this green tick, select this axis and give revolve of this, or else it will be formed automatically when you change the dimensions. Now go with top view, and this is how it got chamfered. Go with the isometric view and you can see. Now hide the sketch. This is the screw nut part that we are needed. Now let's go ahead with part number 8, that is lock nut. Go with sketch, select top plane, uh, draw a rectangle of any length and breadth. Now assign the given dimensions. This is 17 and this is 18.72. Using connect command, select the midpoint of this and select this axis and select this and select this one. Now as we had done part 7, again go with select the midpoint from here, draw a line of any length of 60 degrees. Now from here again with any length, draw a line of 120, draw a line of any length at an angle of 120. You can see to verify with using the angle between command. This is 60 and this is 60. Now draw the line from here at an angle of minus 60 degrees from here, or minus 120. Trim off. Now we have got hexagon here. Trim off the excess part. From here to here it would be 18.72. From here to here it would be 70. Now go with return. Using the protrusion, select this sketch, click on green tick and give a protrusion of distance 5. Left click and now we have got the protrusion. Hide the sketch. You can see This is the top view. Now we have to make a hole in it. Use the hole option. Select the front, top plane. The top surface of the protruded part. Now go with the hole properties. The type of hole is simple and threaded. Use threaded type. Select the diameter as 10 and the thread form is M10 to the whole extent. Click on OK. Now place it at the center. Go with return. Take to the downward direction. Now we have got the hole, as you can see, with the thread form. Now we have to chamfer it at the edges. Go with sketch. Select front plane or else select the right plane. See that whenever you want to chamfer, select such a face that it should have least number of faces. Now again make an line. See that it should not be aligned with any of the body part. Let's zoom the region. From here, take any line of any angle. Now using angle between, set the distance between these two as 60. Complete the sketch. Go to return. Before going to return, you have to make a axis line. Again select the tool, go on the sketch number 3, right click and select edit profile so that you can edit the sketch. Now draw a line on this axis and give it as a construction line using construction command. Go with return. Use revolved cutout command. Select the sketch, click on green tick, select the axis and give a degree of 360 degrees rotation. Now you can see chamfer has been made. This is the top view, this is the front view, this is the left, and this is isometric. Now hide the sketch and save the part. Now let's go ahead with the last part, that is part number 9, clamping plate. Select sketch, select top plane, draw a rectangle of any length and breadth at the start. Now give the dimensions using smart dimension command as it is given in the details. This is 50 and even this is 50. Go with connect, select this, select the midpoint, go with connect command, select the midpoint of this line and select this axis and select the midpoint of this line and select this axis. Now you can see it is equidistant at both sides, that is it is 25 here and 25 here. Now go to return, select protrusion, click on green tick, select symmetric extent, give a protrusion of 8, hide the sketch. Now we have to make 2 holes. Select with hole option, select the top surface of the protruded part, click on the hole properties. Now the type of hole that we are going to do is a countersink hole. The diameter is 6.3 of the hole and the countersink diameter is 12. It is to the hole extent and click on OK. Place it here. It should be placed at 25 distance from the this line. It should be 25 distance from this line. Click it here somewhere and make another hole here. Now you can check using the dimensions. It is 25 and the distance between the two holes is 24. From this to this it should be 12. Now the holes are equidistant from this axis. Now go to return, select the downward direction. Now you can see the countersink hole has been made. This is the top view, this is the front, and this is the isometric. Now as we are done with all the parts, let's go ahead with the assembly. Select the assembly and give the path where you have the saved machine wise parts. Summon the first part and now summon the second. Go with the axial align in the first click on the assembly, go with the axial align, select this circular part, cylindrical part, and select this. Now again go with assembly, select axial align, select this cylindrical part and select this. Now they are actually placed, as you can see. Now using move option, select this part, move it to the right and place it somewhere here. Now you can see they are axially aligned. Now bring the third part, that is jaw grip. Again go with assembly, select axial align, select this and this, and again go with assembly, select axial align and select this and this. Move or else use mate, use this to this. Now it's placed. Now again summon the third part, go to assembly, select axial align, select this and this, and select this. Go with assembly, select axial align, select this part, this cylindrical part, and select this cylindrical part. Now these are in same axis, that is actually aligned. Again go with the assembly, go with mate option, select this part to this. As you can see, these are placed using mate option. Now you can summon the ninth part and go with assembly, go with axial align, select this cylinder and this, move it. Now go to the assembly part finder, use move option, click on it, move it to the bottom, go to assembly, go with mate option, select this part and select this. Now again go with assembly, go with axial align, select this and this. Now you can see these are axially aligned. Now summon the fifth part. Select move option and select rotate. Click on this and rotate it. Now go to assembly, go to axial align, select this end of the cylinder and select this. Now you can see these are axially aligned now. Go with front view, select move option, select move. Now drag it right side, select detect collisions, move it, select visible and hidden edges. Now you can see it is placed exactly. Now go to isometric view, summon the part number 6, that is washer. Go with axial, go to assembly, go to axial align, select this part and select this. Go with the front view, go with move command, select this part, bring it backward, go with visible and hidden edges, move it and place it. Place it exactly here. Now you can see it is placed. It is placed exactly. Now go with the isometric view, summon the part number 7, first part number 7. Go with assembly, go with axial align, select this cylindrical part and select this part. Again go with front view, go with move command, bring it backwards, go with visible and hidden edges, bring it back, and place it exactly to the washer. Now you can see it is placed correctly. Again bring the part number 8. As usual, go to assembly, go to axial align, select this cylindrical part and select this. Go with front view, go with move command. Sorry, before that, this is in an inverted way. Delete this, summon the 8 part, go with axial align, select this part, select this part, check it once, put the left view. Again it is placed. Go with front view, delete this. In part number 8, go with axial align. Select this cylindrical part, select this. Check it. Zoom the area. Rotate it a little here. Now it is placed correctly. Go back. Go with front view. Go with move part. Move it to the last screw. Sorry, last nut. Move it. Select. First go with the visible and hidden edges. Move the part number 8. You can see it is placed. The lock nut has been placed on the nut. You can move it a little left also. Now go with the part number 4. Click on assembly, click on axial align, select this and select the cylindrical surface and go with front view, select the part and move it. Go with visible and hidden edges, move the part and place it exactly. Now again summon the 4th part, go to assembly, go to axial line, select the cylindrical part and select the cylindrical part of this one. It is placed inverted. Don't worry, go to rotate. Or else select this, delete it. The body part, summon part number 4, go with assembly, go with axial align, select this part, sorry, go to assembly, go to axial align, select this part and select this part. Go with front view, use move option, select move, select the part, move it and click on visible and hidden edges, move it and place it exactly in the hole. Now go back to isometric view. You can see the both screw have been placed in the holes. Now again summon part number 4, go to assembly, go with axial align, select the cylindrical part and select the cylindrical part of this one, go with move command, go with front view, go with move, select this part and move it, select the visible and hidden edges, move it and place it exactly in the hole. Again summon the 4th part, go with mate, select this part and select, sorry, not mate. Go with axle align, select this, go with front view, select the move command and move it, go with this, place it exactly. Now again select move and select this, try to place it exactly in the hole, and now the holes are exactly placed in the, sorry, the nut are exactly placed in the holes. Now again go with the part number 4, go to assembly, click axial align, select this and select this, go to assembly, select axial align, select this part and select the cylindrical part, or else delete this part, go with front view, summon the part number 4, first try to revolve it once, now go with axial align, select this and this, need not worry if it goes inside, go to move option, select assembly pathfinder, go with part number 4, part 4 in that 5, try to bring it down, go with move command to bring it down. Now go with front view, bring it upwards, bring it upward and place it exactly in the hole. Again the same, go with the front view, go to path library, summon the part number 4, use the move option in that rotate, select the part and try to rotate it like this, go to assembly, go with axial align, select this cylindrical part and select this cylindrical part. Now it has went inside, need not to worry, go with front view, go with move option, select move part, go to assembly pathfinder, go to part 4 in that 6, try to bring it down, go with visible and hidden edges, again click on move, click on this part, bring it upwards and place it exactly in the hole. Now go to isometric view. Now as you can see, all the parts have been assembled. This is how an assembled machine vice looks. This is the isometric view, this is the front, this is the right, this is the left, this is isometric, and this is the bottom view. Now as we are done with all the parts and assembly, let's convert this assembled machine vice 3D to 2D. First save the assembly, then go to file, go to create drawing, click on OK, Now click on next, go to customs, close it, and click on the views that you are in need of, click finish and place them. Now go right click on sheet 1, go to sheet setup, go to A4, close the show background, click on OK. Now place this two inside the page and delete this if as it is not in need. Now use the cutting plane, select the diagram from the center, draw a line and go click on finish, name the views as section A and as the section name the section line as A and A. Go to section view, click on the sectional line and bring the diagram upwards. Now you can see the sectional view and the top view of the assembled machine wise.